This UCSD TV program is presented by University of California Television. Like what you learn? Visit our website or follow us on Facebook and Twitter to keep up with the latest programs.
Hello, and welcome to Computing Primetime, a conversation on the role of computing in the wider world. I'm Ryan Kastner, a professor of computer science and engineering at UC San Diego.
And I'm Albert Lin, a research scientist at the Qualcomm Institute and an emerging explorer of the National Geographic Society. In this program, we're going to explore computing and technology for exploration. Just as computer science is reshaping disciplines such as biology, it's also fundamentally changing the field of exploration and cultural heritage.
There are numerous projects underway at UC San Diego in places as far-flung as Guatemala, Mongolia, Jordan, and Italy. But we'll get to that in a moment. But first, Albert and I are co-directors of a student program called Engineers for Exploration. And that's probably a good place to start the conversation. Albert, you were an engineer by training, yet you got into exploration somewhat recently. So can you tell us a little bit about how you got into that exploration coming from the background of engineering?
I'm just a crazy person, and my PhD advisor was equally crazy and always going out into wild, far-flung places. That had a big influence on me. But I did actually all of my degrees in engineering here at UC San Diego. I was an undergrad here, I did my master's here, I did my PhD here, all in the fields of mechanical, aerospace, material science. And there's really cool stuff happening on campus all the time, right? And I remember feeling kind of trapped, feeling like, okay, well, what am I going to do next? And then I heard this talk by this guy who was invited to speak at the Qualcomm Institute, which at that time was called Cal 82. His name was Maurizio Seracini, and he was using his degrees and his training in bioengineering to look for this lost painting between two walls that he believed were in the Hall of 500, the Piazza Vecchio. This is the chamber that locks in Leonardo da Vinci's all-time masterpiece. I thought, oh my God, that's exactly the kind of thing I want to spend my time doing. At the same time, my parents and grandparents had always told me to go back to understand my own culture. And when I finished my PhD, I spent a lot of time in Asia, and I came back to the US with this strong feeling that I could take that idea of engineering and combine it with my desire to explore the world and just merge it together. But that's nothing new, if you think about it, engineers have been doing this forever. Do you know who founded the National Geographic Society?
Alexander Graham Bell.
That's right, yeah. So the inventor of the telephone actually is one of the founders of the National Geographic Society. An engineer, right? You're an engineer. You've been in exploration for a long time as well, right? You've done incredible things with computing. What got you into it?
Before I came to San Diego, UC San Diego, I was a professor up at Santa Barbara, UC Santa Barbara. And if you've been to Santa Barbara, the campus, it's right on the ocean, right? So what I would do to sort of clear my mind when I started as a young professor, with a lot of stress to try to get tenure, is I would just walk down on the beach, right? And the buildings right on the cliffs of the beach are the most amazing buildings, right? Because you just have this office with an ocean view.
Wait a minute, so you're telling me that to work hard, you just strolled along the beach?
Absolutely, right? You have to do that, right? It's important to clear your mind, right?
All right, yeah.
It's important to clear your mind. Amazing things came to me. So I went down there and I said, first off, I need to get an office on the ocean with an ocean view. So then I figured out, how can I do that, right? Second off, so most of the offices down there were marine science and ecological offices, right? So I said, well, I need to approach these people and try to figure out how can I get involved with them, right? Because the way I see it, in computing and engineering, we've come a long way, and things are advancing at a tremendous pace, right? So if you look at the past 50 years in computing, we've gone from computers the size of this room to things that are now even more powerful, just sitting in our pocket or on our watch, right? So all that fundamental stuff is there. It's already to be used. So how do we actually use that for biology, for ecology, for exploration, right? So I met up with some ecologists, marine biologists in particular, and I said, how can I get involved with you? Well, we really want to do some exploration of the ocean, right? So the ocean is a vastly underexplored place. We know more about the surface of Mars, the surface of the moon, than we do about the ocean floor, right? So they were very forward-looking people. They have this research center. Actually, it's a UC research center in French Polynesia. So it's a terrible place to visit, right? And terrible place to do research.
Yeah.
So I said, well, maybe I'm not going to get an office as a young professor, an ocean view office, right? But maybe I can go to French Polynesia, to this island of Moorea, and take some of the technology that is in computing and actually put it underwater and help them discover things about coral reefs.
Yeah.
The state of coral reefs, sadly, they're dying at a tremendous rate. So how can we use some of the technology to discover how they're dying, and how can we regenerate them, right? How can we make them regrow? So one of the biggest things that they had at that point was the lack of ability to talk to the sensors. They would take disk, probably floppy disk, and they would literally walk it to someone. So they called it a sneaker net, right? And so they took this term off of sneaker net, back 30 years ago, before internet was widespread, and they said, really what we're doing in the underwater world is like that, and they called it flipper net. So what they do is they put sensors down underwater, right? They leave the sensors in the ocean for a year, and they come back and grab them, right? And then they grab the data off, and then they put it on the internet and they share it. But bad things can happen, right? Your sensor could just crap out, right? And then you
have
no status,
no data for the entire year.
Yep.
And you're basically going to have to take long walks on the beach.
Yeah, exactly. That's
it's terrible, right?
Yes, right.
And
or spend another year as a PhD student, right?
Which is not the worst thing.
It's not the worst thing, but
it's
it's potentially not the best thing. Right?
Honestly, it's probably the best experience.
And actually, it is a
pretty
pretty good life. I often want to go back to my PhD years.
Yeah.
And, that's why I think in terms of my motivation for the engineers for exploration is
to be closer to the students.
Be closer to the students, right? Be closer to the undergrads, right? Because the undergrads have this amazing energy, right? And so I joke, but it's like we can live in Neverland, right? We can live in this place where the students are just constantly staying young, and we can just suck their energy and try to be young.
But for me, I mean, the experience as an undergrad here was remarkable. I feel like UCSD is one of those places where you can dream up pretty much anything and make it happen, only if you decide to. If you don't, then you're not going to do anything, right?
Yep.
But I also felt like I wanted to get more, in general, I wanted to do more than what I was just doing in my classes, right? I mean, the classes were great, but I wanted to do more. So, what we're doing with the Engineers for Exploration program, in my mind, almost originally was in part as almost like a reflection of what I wanted when I was an undergrad, but also it was because I just needed people that were innovative to try to help build stuff that we were going to use in the field, right? I mean, if you remember,
going back to it was 6 years ago, right? The start of the program. Maybe I want to hear your side of the story first, and I'll tell my side of the story.
You go first.
Okay, so this crazy guy, Albert Lin, comes comes to me and says, I want to build some technology to take with me to Mongolia to find this tomb of Genghis Khan, right? That's the way I saw it, right? And how can we do that? And I specifically remember saying, do you think we can get students excited about this? Like, do you think that's students that'll be something that's important to the students? I'm like, oh my gosh, this is amazing. Let's do this. Let's absolutely do this. Right?
Yeah, I remember feeling pretty desperate, because fresh out with a PhD, no job, trying to build this project on fumes of funding, and then walking into your lab and seeing a robotic submarine built by students, seeing other things that were happening from an embedded circuit standpoint, really cool toys. And what I wanted to do was take that approach to land. So, I was up in these mountains of Mongolia. I had satellite imagery, like big, vast quantities of satellite imagery, and actually with some incredible students here, came up with ways to crowdsource the analytics of that. And then we had places we wanted to go, but we knew we wanted to look, at this area that we couldn't dig up, so we had to see from above. And that guy Maurizio had talked about using thermal imaging to look at the changes in the soil from day to night in terms of the thermal conductivity, and that way you could see a void. And I thought, okay, that's totally how we're going to do it. But at the time, a drone, an aerial UAV, which now you can buy for a couple $100, 6 years ago, the cheapest one was $20,000. I mean, remember, and we were talking about that. It's like, well, can we
build one? Yeah.
Can we just get some students to do this?
Right.
Can we can they build this thing?
Yeah.
And then obviously somebody needs to fly it. So can we get permission to take some students out to this incredibly dangerous, uninhabited, unexplored region? And what would be the liability of that?
Yeah, no, exactly. It's actually an amazing point that you just brought up is, going 6 years ago from a copter that was $20,000 to now, just 6 years later, it's $100. Or you can buy even small ones that are like $10. They're toys now, literally toys. So the rate of explosion of the computing and just kind of this maker space and what can I do and make it more, build it cheaper. Has really driven, I think, computer science exploration and just computing in the larger world.
Yeah, I also remember, and you spent some significant time there afterwards as well. But when we first started the program, it was funded by National Geographic,
right.
And I'd gotten a small grant. But what was cool was that they have a engineering lab in the society, right, where people are just tinkering and building robots to go and do the impossible,
yeah.
Right? They've actually incorporated, as you know, a lot of the technology that we were innovating right here, and we have innovated and continue to innovate, I mean, the fact that some of our students from our program now actually work in that lab and get deployed all over the world,
right.
is something that makes me think, well, maybe I should become a student in my own program.
Go work at National Geographic. Right? It's an amazing place.
Sounds awesome.
Through the connections through this program, I got to spend a few months there about 2 years ago working on the Critter Cam.
Yeah.
Right. So this is an amazing device that they put on hundreds of different types of animals. It's just a camera, right? And again, this points to the fact that when they started the Critter Cam, probably in the late '90s, it was this rather large thing, and now it's just minuscule. Right?
How big is it now?
Well, it depends on the animal, and it's a lot about battery power and how long they want it to stay alive.
You brought up something that happens in almost all our projects. It's student-led and focused, but really the projects are beyond just a student experience. These are real-world challenges, right? I mean, we've had students come with us to expeditions. Like, for example, we were just in Guatemala last year on two expeditions where we had students using all sorts of gear, but they have to think about, when innovating, they have to think about battery power, right? They have to think about connectivity, data analytics afterwards, stability, geopositioning, like all this stuff that goes into each one of these platforms. So when you look at actually our student base, it's sort of like a jack of all trades approach where you have to know a little bit of everything to put it together, right?
Yeah, and you get that experience again, looking back to what could have I done as an undergrad, right? You get that experience, I think, of taking what you learn in your classes, but going just so far beyond that, right? Saying like, I'm not going to learn how to make a flying vehicle. I'm not going to learn how to do that in any of my classes. I'm going to learn the basics of that, but then I have to go out and try to figure out how to take that knowledge and use it. And it's not just computer science. It's it's mechanical engineering, electrical engineering, computer engineering, aerospace engineering. So it really involves this collaborative mishmash of students and disciplines across engineering.
And you got to be in physical as well. I mean, you got to be an athlete in some ways, right? Like I actually remember in grad school, most of my friends that were at ECE or CSE or I don't know, there was just a huge community of rock climbers in this discipline for some reason, right? And so I was really into climbing, and we took a lot of that physical adventurous spirit and brought it into the field. And actually, in I think it was 2009 or 2010, our project, a bunch of computer science PhDs or almost PhDs, and I'm a mechanical engineer. We were National Geographic's Adventure Magazine's Reader's Choice Adventurers of the Year. So I mean, Adventurers of the Year being engineers.
Yeah.
And I think that's just the beginning, right? I think about now the frontier of beyond just the physical and looking at what we can see now of our planet. And I think we're at the very tip, the very beginning of an entirely new world of data-driven exploration. I mean, you look at, for example, the fact that I just got this email today saying that we're going to be able to tap into, at UCSD, have this unbelievable potential to look at all of the satellite imagery that's being produced by this constellation of 6 satellites from the leading satellite imaging company in the world, Digital Globe. And that's 500 million square kilometers of imagery that's each pixel is about the size of this table, right? Now, if our students can do anything, they can innovate, right? And so what if we start thinking about how do you look at that data at huge scales? How do you compute insight out of that imagery? The things that we can see, you can't get to. Like we could go and explore the Amazon and look at the indigenous communities that have never been contacted before from space, and understand how they're moving and how they're interacting, where the conflict zones are. I mean, the potential is endless. So it's, I think it's not just robotics that is impacting exploration, but everything from data science to analytics to machine learning to crowdsourcing. I mean, it's just the beginning.
Yeah, absolutely. So that another big trend that you've seen in computing, especially recently, is that we have these 4 billion transistor mega processors just sitting in our pocket, and they're just always collecting data, right? People are always taking pictures, videos, putting it on the internet. There's the ability now with just these amazing satellites to get this super accurate resolutions of all around the world, multiple times a day. But we have so much data, right? Yeah. So how do you deal with that, right? That's a huge problem. It's like we have the compute power. We have these massive farms that Google runs and Microsoft runs, Amazon runs. We have all this data stored somewhere. Probably 99.99% of it is just useless stuff, pictures of cats on the internet, right?
Yeah.
Useless stuff. But you have all this data, right? And there is some very, very useful data in that 0.00001%.
Oh, yeah.
And how do you get out of it, right? And you did this in many years ago looking for the tomb in Mongolia, the tomb of Genghis Khan. So can you maybe explain a bit about how you took this vast amount of data and tried to figure out what is interesting in this data?
Yeah, well, so I was at Cal ICT, and I told you about the idea that we're trying to look for Genghis Khan's tomb using satellite imagery to begin with to locate areas of interest in this massive unexplored region. There was actually an area north of the capital of Mongolia, right on the border of Siberia, that was around 6,000 square kilometers in size and was forbidden to go to by anybody outside of the imperial family for 800 years, by decree of Genghis Khan himself. So untouched, right? Except for these shamans that could go and pay worship to the sites where the tomb should be. So we thought, okay, let's look for satellite imagery. Let's look for anomalies, anything that's on the ground. But we couldn't get through all of it in a single lifetime, really, because each pixel was, we had to look at every single one, right? So we thought, can we use some computer vision algorithms? I was really lucky because at QI, in Cal ICT, there's students from all different disciplines. So one of my friends, Shai Harnoy, he was, I think a CSE major in image processing. We tried to do some work there and see what we could find. We tried to do some machine learning with Kostas Stamatilou, another PhD student in QI. And then Luke Barrington, who was doing his PhD with Gert Lancrete, Gert, Professor Gert Lancrete? Yep. They were doing this really cool project on getting people to tag music with games, and to put labels on music. And Gert's another one of the explorer groups. He's really one of these guys who just is out there pushing the limits. And I talked to Gert and Luke about my problem, and right away we thought, well, how do we tap the crowd to do the analytics, right? So we sliced up the imagery and came up with this process to have people looking at little bits of data, and in parallel they would find places of agreement, and that would lead us towards a mathematical approach to identifying where the hottest spots were. And then we'd go out on horseback. Well, it worked so well that Nat Geo put it on their front page. It got millions of hits. We found 55 tombs, one of which we think is actually incredibly compelling. Possibly, I can't say much more than that. But then the whole process was so successful that we launched a company called Tomnod. I don't know if did you see that Malaysia Airline first plane that went missing, and there was this big crowdsourced search with 8 million people. And we sold that company, and to Digital Globe, who's the satellite imagery provider, only 2 years after we started.
Right.
And the fact that we could go from just a concept to a company, to an acquisition, to a global impact of 8 million people within a couple of years is an example of what you can do as a student thinking about computing and exploration.
Yeah, no, I think that all kind of pulls back to the point I was making earlier about how things move so quickly, right? And if you can get the right problem, you can jump on them, and you can be passionate about, and you can find the right people, right? So it's usually not like the person that's right next to you, but it's a person that's across the hall or across campus that you can talk to and say, hey, I have this amazing problem, and they have a lot of solutions, right? And they can come and say, this is Gert for you, I think, right? So you guys were not too far apart, but you have to find that kind of person, and you say, I have all this data, I'm looking for weird stuff in it, and he's like, well, I'm doing all I have all this music data, and I'm looking for something similar to what you're doing, but it's not the same. It's not obvious to him. It's not obvious to you. But when you come together in a collaborative way, then it makes a whole lot more sense. And I think that talking about the Qualcomm Institute Cal IT, that's a huge aspect of that, right? Is that you have all of these people from all over campus sitting there, and they're not across campus now, right? They're right next to, they're across the hall from you, and then it creates this amazing collaborative experience that you can take a music person and an engineer and electrical engineer and a materials engineer, mechanical engineer, archaeologist, and so on.
I mean, bringing that up, one of the things that we have that's a really big resource for the program, for the E4B program, is one of our other co-directors, Kurt Trugers, is the director of this crazy little lab where you can just tinker. Yeah,
going back to the whole makers movement, which is it's like almost like as computing has expanded, so has mechanical engineering expanded in some sense. So I can relatively easily just make whatever I want, drop a 3D crazy design and then give the file to this little printer that spews ink, and creates a 3D printed object of whatever it is that you need, right? And so that enables you not to have these huge machines that were traditionally operated by people with missing one or two fingers, right? Because it's they're very.
I miss that. Come on, you need those guys.
You have all your fingers though, so you're all right.
But there's also some really.
But it's much easier now, right? It's much easier to do that, and that's another huge innovation,
stuff, right?
right?
I think there's a place for both, right? I mean, there's really a place for both, because if you look at some of the stuff that we build, it's still that hammer, lose your finger sort of thing.
Definitely, yeah.
And it's still in that lab. That lab also has
we have all that access
and
to
everything
it,
like that. But Kurt is an example of another one of us who loves to build and tinker and then go into the field.
Right.
So I've felt strongly over the years that engineers should not think of themselves as cogs in a wheel to then deliver something for somebody else to deploy. We're the ones who know what to do with these things and how to fix them, because field work is just unpredictable. Everything breaks.
Yeah.
So you got to be there to actually fix it with duct tape or twine or whatever.
And you have no idea what it is until you get to the field. So going back to the Guatemala trip, that first trip, that that 2-day crazy jaunt into the jungle, right? It's like we had no idea what to expect, right? So. My father, bless his heart, he always thinks I go to crazy places like Europe. He's like, you're going to Switzerland? Ryan, you got to be careful, right? And I told
cheese there, it's really bad for you.
Yeah, the chocolate, right? It's going to kill you, right?
Yeah, don't do that.
And I reluctantly told him, like, hey, Dad, I'm going to Guatemala. And he's like, where's that? It's like, oh, well, it gets better, Dad. It's I'm going into the middle of this jungle,
war-torn jungle.
Yeah. Where exactly? There's Maya ruins, but I didn't tell him any of this, and hopefully he doesn't watch this, right?
Yeah.
But all this sort of activity of violence, drug violence, and all this kind of stuff, and we're going to go there, and it's going to, I didn't even know at the time, but it took us 5 hours to get in through on muddy roads.
More than that. I thought it took us almost a full day of pushing those Land Rover Defenders. I mean, these classic Land Rover Defenders,
like tanks almost, right?
I actually felt like we were on the Indiana Jones ride.
Yeah, no, exactly.
Because it was so muddy that the truck would just be sliding around everywhere, and then watching our students who were, green from getting off that plane, literally green in the face.
Well, I was too, but
that crazy plane we had to take from the Capitol with the bars on the windows, and then jump out. They've got these big copters, these big robotic drones sitting on their lap, because they don't want to break it down.
And the LiDAR, the $30,000 LiDAR.
And this $30,000 laser scanner, huddled around them to make sure it keeps safe. And then they had to carefully put it down, get behind this truck, and just push it through the mud for, I don't know,
5, 6 hours. And it was only 10 miles or something we went, and it took us that long to push these monster tank of a vehicle through this.
But I like when Tom Garrison, our collaborator, the archaeologist, turned to everybody and said, well, here's your anti-venom, but it's really, you got a 50-50 shot if the snake gets you. And then he points to the snake skin that's hanging right on the outside of the temple.
Yeah.
and none of our students were phased at all whatsoever.
Yeah.
That was pretty cool.
Yeah, no, that was, bringing back to, Tom had to do this briefing because the UCSD wanted us to have this briefing. It was required to brief the students. He was like, everyone here's the antiventum, and I think someone asked, what do we do if we get bit by a snake? And he just looks at you, and Tom is just so stoic, and he's like, don't get bit by a snake.
Yeah. That's terrible. Didn't you see a snake in one of the
Yeah, on the second trip. So, we were, maybe to give a kind of step back a little bit, but, that first trip was just this crazy, fly down to Guatemala, to get on this little puddle jumper to the Petén region, take these monster trucks, literally monster trucks into the middle of this biosphere into the site, El Zotes, which is what they thought was a major site next to Tikal, which most people know where
What
Tikal
does El
is.
Zotes mean?
Zotes is bats, right? It's the Maya word for bats, right? And going in and doing all that craziness, and we just took a bunch of stuff, right? We had no idea what to expect, right?
Yeah.
I didn't even think that it would take this long. We took all this technology in. We were going to take a freaking balloon, right? And
that
was going to be the worst idea.
A big helium balloon,
balloon.
a massive helium balloon.
Yeah.
That, by the way, we've used for looking for like all sorts of things, like whales in the Pacific.
We used it in Jordan, an archaeological site
with Tom Levy.
Yeah. So we were like, oh yeah, we'll take the balloon, right? And we were looking to get helium in there, which was going to be a big disaster. And luckily we couldn't get helium in there because we get there and we look up and it's just jungle, right? And
They were going to
"There's no
hire
way."
some guy to drive a helium tank from Belize
Yeah,
all the way
right,
to Guatemala for us.
Yeah,
but-
and we would have gotten there and we would have just been like, nope, we can't use the balloon. But we took the copters, we took the LiDAR, and we did all of this different kind of stuff, and we tried to figure out what was useful, right?
Yeah.
Just spend 14-hour days just around the site, flying and doing LiDAR scans.
I remember there was an issue when we were on top of one of the big temples, and they started flying. A couple of the students, Dom and Eric, they started flying one of these copters up to do some mapping and test this drone for obviously the project that we're building now to put a laser on the drone to map the jungle. But for some reason, the location on Earth wasn't correct based on our GPS and recalibration or whatever. So they send up this drone and put it into its flight path, and it just goes off in the wrong direction. Like for a long ways until we can't even hear it before, right? And then I turned to Dom and I said, Dom, go back to manual controls.
Yeah.
So he gets back to manual controls. And you had a radio down.
Yeah,
in the
we were doing
canopy
LiDAR
in the jungle,
scans of
right?
some of the stelas, some of the wood, the stone carvings that they put outside of the temple. So I was over there with Perry, and we had radio so that we could talk to each other. But
And we couldn't see it anymore. So I remember calling down to you.
no, I was like, oh, I see the copter. It's flying over us right now. And you were flying it off the top of one of the temples, which was pretty cool, right?
And pretty terrifying too, because those temples are high up in the canopy.
Yeah, they're higher. They're above the canopy, right? So that's why we chose to do that.
Surrounded by those howler monkeys.
Howler monkeys, yeah.
So they're screaming at you while you're trying to do this stuff with your computer and see where the copter is.
Yeah.
And communicate with you guys to try to triangulate this piece of gear.
Yeah.
Man, that was so much fun.
Yeah, it was a good time.
See, I think that's the essence of the engineering experience that I imagined when I was a kid, thinking about what it would be like to be an inventor. You think about what engineering is, it's an incredibly romantic experience of creativity. You just come up with something and you make it work, and then you apply it to really cool stuff.
Yeah.
It's a great time to be an engineer.
And a computer scientist.
I guess we have to leave the conversation there. Thanks for watching this edition of Computing Primetime. I'm Albert Lin.
And I'm Ryan Kastner. Thanks for watching, and be sure to follow us online at csc.ucsd.edu and e4e.ucsd.edu if you're interested in learning more about our Engineers for Exploration program. Join us next time.